Most people think eyesight changes slowly over years. They imagine vision getting weaker little by little as they age. But something important happens to your eyes every single night while you are asleep. Your eyes are not simply resting. Inside the back of the eye is a thin layer of tissue called the retina. This layer is responsible for turning light into signals that your brain can understand. Inside the retina are tiny specialized cells called photoreceptors. These cells detect light and color. Every day, those cells work constantly. They process millions of light signals. They help you read, recognize faces, drive, and navigate your environment. Because of that constant activity, the cells in your retina experience continuous stress. That stress comes from something called oxidative metabolism. In simple terms, when cells produce energy, they also produce small, unstable molecules known as free radicals. These molecules can damage cell structures if they build up. Photoreceptor cells are especially vulnerable because they use a large amount of oxygen. The retina actually uses more oxygen per gram of tissue than most other parts of the body, including the brain. This means the retina must constantly repair itself. A large part of that repair happens during sleep. While you sleep, your body enters a different biological state. Blood pressure drops slightly, the nervous system becomes calmer, energy demand from muscles decreases. Because of this shift, the body can redirect resources towards cellular maintenance and repair. In the eye, one important process involves the renewal of photoreceptor outer segments. Photoreceptors contain structures that absorb light. These structures gradually wear down as they process visual signals. Each night, the body removes damaged portions and replaces them with new material. This process is sometimes described as photoreceptor renewal. Without it, vision would slowly deteriorate much faster. Another process also becomes important during sleep: antioxidant protection. Antioxidants are molecules that neutralize the free radicals produced during metabolism. When antioxidant defenses are strong, cells can repair damage more effectively. Many nutrients involved in eye health function as antioxidants. These include certain vitamins and plant compounds that help stabilize retinal cells. This is where diet begins to matter. The retina does not produce all of these protective molecules on its own. Some must come from the foods you eat. When these nutrients circulate in the bloodstream, they can reach the retina through a network of tiny blood vessels. Over time, certain compounds accumulate inside the retina, especially in the macula. The macula is the small central region of the retina responsible for sharp central vision. It allows you to read small text, recognize faces, and see fine details. Protecting this region is one of the most important goals in long-term eye health. Large population studies have explored how diet relates to eye disease risk. One of the most influential research programs in this area is the Age-Related Eye Disease Study, often called AREDS, conducted by the U.S. National Eye Institute. AREDS showed that certain antioxidant nutrients are associated with a slower progression of age-related macular degeneration in high-risk individuals. The findings helped establish the idea that nutritional support can influence retinal health. This does not mean food can cure eye disease, but it does show that nutrients involved in antioxidant defense can affect how the retina handles stress over many years. Now consider what happens at night. During sleep, the retina is actively clearing damaged material and rebuilding structures that were used throughout the day. For that repair to occur efficiently, the cells need access to the raw materials that support antioxidant protection and cellular maintenance. Those raw materials come from circulation, and circulation reflects what you ate earlier. This is why timing sometimes enters the conversation. Some clinicians encourage patients to maintain a steady intake of nutrient-rich foods across the day, including the evening, so the body has access to those compounds during nighttime repair processes. This does not mean eating right before bed is always necessary. But it highlights an important principle. Eye health depends on long-term nutrient supply, not occasional supplements or short-term changes. Another key factor is the type of nutrients reaching the retina. Certain plant pigments, known as carotenoids, have attracted attention because they accumulate inside retinal tissue. Carotenoids are responsible for the bright colors seen in many fruits and vegetables. Inside the eye, some carotenoids help absorb damaging light and neutralize oxidative stress. Over many years, this protective effect may help preserve photoreceptor function. Several observational studies, including analyses from NHANES, the National Health and Nutrition Examination Survey, have found associations between higher dietary intake of carotenoid-rich foods and markers of better visual function. Associations do not prove cause and effect. Still, the biological mechanisms make sense. Antioxidants support cells that constantly face high metabolic stress. And retinal cells experience that stress every day. When people begin to notice changes in their eyesight, they often assume the damage occurred recently. In reality, many of these processes develop slowly over decades. That is why protecting retinal cells early matters. Small daily habits accumulate over time. What you eat consistently can influence the environment those cells live in. And some foods provide nutrients that are particularly useful for retinal protection. One fruit in particular has attracted attention because it contains compounds known to support both antioxidant activity and vascular health, two factors that matter for maintaining healthy retinal tissue. In the next section, we will look at the fruit many doctors recommend when discussing nighttime nutrition and eye health, and explain what makes it biologically relevant. But understanding that recommendation requires first seeing what is inside that fruit and how those compounds interact with the retina. The fruit most often recommended by doctors when discussing nighttime nutrition and eye health is the blueberry. Blueberries are not a miracle food. No single fruit can prevent all vision problems. But blueberries contain a combination of compounds that interact with several systems involved in maintaining retinal health. The key compounds inside blueberries are called anthocyanins. Anthocyanins are plant pigments that give blueberries their deep blue and purple color. These pigments belong to a family of molecules known as flavonoids, which are widely studied for their antioxidant effects. Inside the body, antioxidants help neutralize unstable molecules called free radicals. As explained earlier, free radicals form naturally when cells produce energy. Photoreceptor cells in the retina produce large amounts of energy, which means they also generate oxidative stress. Anthocyanins can help reduce that stress. Laboratory studies have shown that anthocyanins can stabilize cell membranes and protect delicate tissues from oxidative damage. In the retina, this may help maintain the structure of photoreceptor cells over time. Researchers have studied this relationship for many years. One large observational study published in the American Journal of Clinical Nutrition in 2014, using data from the Nurses' Health Study and the Health Professionals' Follow-Up Study, found that higher intake of flavonoid-rich foods, especially berries, was associated with a lower long-term risk of certain eye conditions, including age-related macular degeneration. These studies cannot prove that blueberries alone protect eyesight. Many lifestyle factors are involved. Still, the association has been strong enough to attract ongoing scientific interest. Anthocyanins appear to affect more than just antioxidant activity. They may also influence blood circulation. The retina depends on a network of extremely small blood vessels. These vessels deliver oxygen and nutrients to retinal cells. When circulation in these microvessels declines, the retina becomes more vulnerable to damage. Some studies suggest anthocyanins may improve endothelial function. Endothelial cells line the inside of blood vessels and help regulate how those vessels expand and contract. Research from the European Journal of Nutrition in 2016 reported that anthocyanin intake from berries was associated with improvements in vascular function markers. Better vascular function can support blood flow in many tissues, including the retina. This matters because retinal cells are extremely sensitive to changes in oxygen supply. If circulation becomes inefficient, the cells experience greater stress. Blueberries also contain vitamin C, another antioxidant involved in protecting ocular tissues. Vitamin C helps regenerate other antioxidants in the body and contributes to the maintenance of connective tissues, including those inside the eye. The lens of the eye, for example, contains high concentrations of vitamin C. Adequate intake helps maintain the chemical environment that keeps the lens clear. But why do some doctors mention eating blueberries in the evening? The explanation returns to the repair processes discussed earlier. During sleep, retinal cells undergo metabolic maintenance. Damaged molecules are cleared and new components are produced. Antioxidants circulating in the bloodstream can participate in these repair systems. Eating foods rich in antioxidant compounds earlier in the evening may ensure that those molecules are available during nighttime repair activity. This does not mean blueberries must be eaten right before sleep. And it does not mean a single serving can produce immediate changes in vision. The idea is much simpler. A consistent supply of protective compounds can support cellular environments where repair mechanisms function more efficiently. In clinical practice, many patients misunderstand this point. I remember a patient in his early 70s who once told me he had started eating carrots for a few weeks because he heard they were good for eyesight. When his vision did not improve quickly, he assumed diet had no effect at all. This situation comes up frequently in medicine. People expect food to act like medication. They expect a visible change within days or weeks. But nutrition usually works on a longer biological timeline. And this illustrates something important about how the body works. Retinal health is not determined by one meal or one fruit. It reflects years of cumulative support or stress. Nutrients such as anthocyanins contribute small protective effects that build gradually over time. Another reason blueberries receive attention is their nutrient density. A single cup of blueberries provides significant amounts of flavonoids with relatively low sugar compared with many desserts or processed snacks. For patients who want a simple evening food option that is both light and nutrient-rich, berries often become a practical recommendation. It is also worth noting that berries are part of dietary patterns that consistently appear in long-term health research. For example, studies of the Mediterranean diet, which emphasizes fruits, vegetables, olive oil, nuts, and fish, have found associations with lower risk of several age-related diseases, including some eye conditions. Research published in JAMA Ophthalmology in 2015, analyzing Mediterranean diet adherence, showed a reduced risk of progression to advanced age-related macular degeneration in participants who followed the diet more closely. Berries are not the only beneficial food in that pattern. Still, they contribute valuable plant compounds that support antioxidant defenses. Another compound found in blueberries is resveratrol, although in smaller amounts than in grapes. Resveratrol has also been studied for its antioxidant and anti-inflammatory effects in various tissues, including ocular cells in laboratory research. Inflammation and oxidative stress often occur together in aging tissues. Reducing these processes may help maintain cellular stability. Again, this does not mean blueberries alone can prevent eye disease. Eye health depends on many factors: genetics, blood pressure, blood sugar control, smoking history, long-term nutrition. Food plays one role among many. Yet blueberries offer an interesting combination of compounds that interact with several pathways relevant to retinal protection. Anthocyanins support antioxidant activity. Vitamin C contributes to tissue protection. Flavonoids may influence vascular function. Together, these properties make blueberries a reasonable fruit choice when discussing foods associated with eye health. Another advantage is that blueberries are easy to incorporate into routine habits. Some people add them to yogurt or oatmeal. Others eat a small bowl of berries as a light evening snack. Because they are naturally sweet, they often replace more processed desserts. Over time, that substitution alone may improve overall dietary patterns. And that is the larger point doctors often emphasize. Healthy eyesight rarely depends on one dramatic intervention. It depends on consistent protection of delicate retinal cells across decades. Blueberries simply provide one example of a food that contributes helpful compounds to that protective environment. Yet understanding what blueberries can realistically do for your eyesight and what they cannot do is just as important as knowing why they are recommended. Blueberries contain nutrients that support the biological environment of the retina, but it is important to understand something clearly. No fruit can reverse established eye disease. Many people hear about foods linked to eye health and assume those foods can repair existing damage. That is rarely how the body works. To understand the limits of nutrition, we need to look at the structure of the retina. The retina is made of several layers of specialized cells. The most important for vision are the photoreceptors, which detect light, and the retinal pigment epithelium, often shortened to RPE. The RPE supports photoreceptors by recycling visual pigments, removing waste products, and maintaining the chemical balance necessary for light detection. When these supporting cells begin to fail, photoreceptors gradually lose their ability to function. Once significant structural damage occurs, restoring those cells becomes extremely difficult. Food cannot rebuild large numbers of lost retinal cells. However, nutrition can influence the rate at which damage accumulates. This difference is important. Instead of thinking about food as a treatment that restores lost vision, it is more accurate to think about nutrition as long-term support for vulnerable tissues. Many age-related eye conditions develop slowly because retinal cells experience stress over decades. Two major sources of that stress are oxidative damage and circulatory changes. Oxidative damage occurs when free radicals accumulate faster than the body can neutralize them. The retina is especially vulnerable because it consumes large amounts of oxygen and is constantly exposed to light. Circulatory changes occur when blood vessels supplying the retina become less efficient with age. Even small reductions in oxygen or nutrient delivery can affect cells that rely on continuous energy production. Compounds found in blueberries may interact with both of these processes. Anthocyanins help neutralize free radicals. Flavonoids may support blood vessel function. Vitamin C contributes to antioxidant recycling. Together, these compounds may help create conditions where retinal cells experience less cumulative stress over time. This idea is supported by several long-term population studies. The Blue Mountains Eye Study, conducted in Australia, examined diet and eye disease in older adults over many years. Researchers observed that higher intake of fruits and vegetables rich in antioxidants was associated with lower rates of certain retinal conditions. Another large analysis from the Beaver Dam Eye Study, a long-running cohort in the United States, also found relationships between dietary patterns and markers of eye health. These studies do not prove that one food protects eyesight on its own. They show something more realistic. Dietary patterns influence risk environments inside the body. People who consistently consume nutrient-rich foods tend to provide their tissues with better protection against long-term stress. Eye health reflects those long-term patterns. Now consider the role of timing again. Eating blueberries in the evening does not activate a special nighttime mechanism that instantly improves vision. The body does not work that way. What the timing may do is support metabolic availability of protective compounds during the period when cellular repair processes are active. The retina, like many tissues, performs part of its maintenance work during sleep. Antioxidants circulating in the bloodstream can participate in those protective processes. Still, the most important factor is consistency over months and years, not the exact hour a fruit is eaten. Another important limitation involves diseases driven by structural or genetic factors. For example, conditions such as advanced age-related macular degeneration, glaucoma, or diabetic retinopathy involve complex biological changes that cannot be corrected through diet alone. Medical treatment remains essential in those situations. The American Academy of Ophthalmology and National Eye Institute both emphasize that nutritional support can complement medical care, but it cannot replace professional treatment for established disease. This distinction protects patients from unrealistic expectations. Food supports physiology. Medicine treats disease. When both approaches are used appropriately, they can work together. It is also helpful to remember that blueberries are only one part of a broader group of foods associated with eye health. Leafy green vegetables contain carotenoids such as lutein and zeaxanthin, which accumulate directly in the macula and help filter damaging blue light. Fatty fish provide omega-3 fatty acids, which contribute to retinal cell membrane stability. Citrus fruits supply vitamin C. Nuts and seeds provide vitamin E. These nutrients appear repeatedly in studies examining dietary patterns linked to healthier aging. This is why many doctors focus less on one superfood and more on consistent dietary habits. Blueberries simply happen to be an accessible example of a fruit rich in compounds that support antioxidant and vascular systems. They are easy to eat, widely available, and generally well tolerated by most people. Over years, small habits like adding berries to a regular routine can contribute to an environment where delicate retinal cells receive better protection. And protecting those cells matters because the retina does not regenerate easily once damage occurs. Maintaining healthy vision therefore depends on slowing cumulative stress before large structural changes develop. That is the true role nutrition plays. It supports the biological systems that keep tissues stable over time. Before we finish, I want to briefly say something about why understanding your body's systems matters. If you care about protecting your long-term health and learning how everyday habits influence your body, you can subscribe to the channel. The goal here is to explain medical science in a clear way so you can understand what is happening inside your body. Healthy eyesight is rarely the result of one dramatic change. It reflects years of small protective decisions that help sensitive tissues remain stable. Blueberries provide antioxidants and plant compounds that interact with systems involved in retinal protection. When they are part of a balanced diet, they can contribute to a nutritional environment that supports long-term eye health. Still, the most important message is simple. Protecting vision begins long before symptoms appear, and the choices made consistently over many years are the ones that matter most.